Here's the circuit setup from the previous lab in case you have to reassemble your LED circuit. Alright, open up lab 6.2.0, and here I'm going to do a comparison of the code, what has changed, and the effects that we should see on that with those changes. The code on the left is 6.2.0, and I pulled up the code 6.1.2, the code that we'd previously run, so we can see some of the big differences. This section right here is where the first change occurs. Everything above this is the same as the previous lab. Alright, the first thing that you might notice is I've changed this variable name. It defaults in CHN, but that actually stands for the channel. And we're going to see what this channel is, but when I call the function button sense, it actually has some parameters that it sends along with that. If I were to have multiple buttons, I would need to know which button is the one being pressed. And so this button sense, the channel, will help us to understand what that is. So I only changed the name. This could say bananas, right? That's my famous way of talking about variables. But channel just helps us to identify that this is part of the channel. The next step is we are printing the channel is, so that's just some text, and I have that in quotes. The plus symbol is a fancy way of saying that is concatenation. What that simply means is I'm adding, think about I have one set of text and I'm adding an additional set of text to that. So I'm not performing a mathematical function, I'm just simply putting at the end of that statement the value of this variable. So channel, as it comes to us, once we press the button and the button sense function is called, channel is an integer. Because it's an integer, the print statement can't print integers. So the integer of 11 has a value, and I could add 11 plus 2 and get 13. So that's why it's stored as an integer. In order to get it to work in a print statement, the data type needs to change from integer to string. So the str casts or changes the data type of channel to a string. So the string, for instance, 11, the string 11, you couldn't add 2 to the string 11, right? It's just the characters represented a 1 and a 1. It is no longer an integer. So this should print out a statement that says the channel is colon space and then whatever the value of the channel is. In our case, it will print out an 11 because that is the channel that the button is connected to. The next modification that I've made to the code is we are going to be looking at the state of the button. So I'm using gpio.input parentheses button to be able to determine whether the input at pin 11 is a high or a low. So this will return a 0 or a 1 depending on if it is a high or low signal. The check button state is calling the function that's right below it, and it says check button state, and I'm passing in a variable. The variable name is button state. So in the button sense function, when I call check button state, whatever I have in the parentheses is going to go in to the value of button state. So button state in this example will equal gpio.input parentheses button. So the state of the button, the state of the pin number 11 when the button is pressed or is not pressed. So the value of button state will be 0 if it is a low signal at pin number 11, and it will be 1 if it is a high signal at pin number 11. So our check button state function should print out the state of the button is, and then it'll be a 0 if the button is low, if the input is low, and it will be a 1 if the input is high. Open up a terminal, and we're going to navigate to our Lab 6 folder. Run a git pull if you need to make sure that you have the most recent code. And we're going to be running the lab 6.2.0. This lab will give us information about the channel as well as the state of the pin. You may get this runtime warning. We're going to fix that coming up soon. But what we're going to do here is we're going to press the button, and it'll give us two pieces of information, the channel and the state of the channel. So here I am pressing the button the first time, and I get the channel is 11 and the state of the button is 0. Press it a few more times and you'll see there's no real change in channel, but one of these times I'm able to get it to return a state of 1. That returning of the state of 1 has to do with the amount of time that the processor is taking to be able to determine the state of that pin. And it just happens to be that the time that it makes that measurement, that's when we get a high state, when we should really be getting a low state every time we press the button. So do that on yours. Press it rapidly or hold it and press it, and you should see similar behavior. We're going to address that in future iterations of the lab. Our next lab is 6.2.1. Here I have both of them pulled up so that we can see the differences. There's no real change in the setup or the variables at the very beginning. You'll notice that I have introduced a new function called an LED, so that def LED. We'll talk about that in a second. We made some modifications to button sense, but check button state is the same. Zooming in on the code, let's look at button sense. So here's what it looked like before. We've removed these 3 lines, so we're no longer printing the channel, we're no longer turning on the LED or checking the button state. What we are doing is we're calling the function LED, and we're using the same input that we did for check button state. So we're saying GPIO.input, and then we pass it button, which is pin number 11. I think the easiest way to understand the LED function is to go through the sequence of steps that the code takes. When the user presses the button sense function is called. Inside the button sense function, we then print out button pressed, and then we call the function LED, and we pass it the information and state of pin number 11. The LED function receives the state from button sense, so the state here is set to equal 0. It then calls the function check button state, which just simply prints out the state of the button. The next line of code is an if statement. So what this is looking for is if this statement is true, execute the code inside the statement. So this statement is if state, which in our case is 0, and then we have a double equal sign, which is looking for a comparison to see if these two values are the same. So if 0 is equal to or the same as 0, then execute this line of code. The next line of code is another if statement. Now we're seeing whether or not the state is in the 1 position or in the on position. So if 0 is equal to 1, so is 0 the same as 1, and that is false. Because this is false, it will skip all of the code that is inside of this if statement. So we skip that line of code. So if we send a 0 in the state position, that will change the GPIO high on pin number R. The other scenario is when we press the button, we send in a 1. So in this case, we would send a function to the function LED. We would send the state of pin 11. In this case, our pin 11 is a 1. At the top, our state will change to equal to 1. So that's the information that we have passed to this section of the code. Check button state does the same thing. It's just going to print out that the current state is a 1. The first if statement is comparing state, which is equal to 1 in this case, and it is saying, is 1 the same as 0? So in our current configuration, this evaluates to false. So when the code evaluates to false, then we're going to skip the section or the code that is part of that if statement. So we skip this line. Next, we'll look at if 1 equals 1. In this case, that is going to evaluate to a true statement, and that true statement makes it so we will execute the code inside of this if statement. So in this example, when we send a state of 1, we execute the second if statement, which turns pin R to a low condition. Let's see what this code looks like. So we're going to run lab number 6.2.1, and we'll execute that. And then if we take a look at our board, when we press the button, we should see that the LED illuminates. So here I've pressed it. Notice that when I press it, I'm getting zeros and ones. So I'm getting these states of 0 and 1. If I hold it too long or press it faster, I'm also getting a problem. So I am turning on and off the light. The problem is the frequency in which I'm doing it. It's not very reliable. So we're next going to look at how to make that a little bit more reliable. The first big change that we're going to make in lab 6.2.2 is this variable at the top. This is known as a Boolean. In this example, we're setting a Boolean with the variable name of LED_on, and we're saying that is in a false state. So a Boolean is either true or false, on or off, 0 or 1. So here we are setting it as a false statement. The only real change that we're making in this part of the code is to the LED function. So the first thing that you'll notice is we have a new term at the top called global LED_on. Global is just a way for Python to be able to gain access to the value of that variable. We've already set the value of this variable, and we set that variable value at the very top in setup, and we said that it would be false. So the first time this code runs, it relies on that initial state that we set this variable in. So this variable is in a false state. So let's run through an event. So I press the button. When the button is pressed, it indicates which channel or which number that I'm getting that button from. And then I send the state of that button to the LED function. So in this case, we're going to give it a state of 0. All right, so the current state of LED_on is in the false state because of when we ran the setup code, we set this to equal to false. But it will change as we continue on through our code. So the first statement that we come to after the LED on is we're going to evaluate what state is this LED on. So right now our LED is in the off state, so this variable is set to false. So I'm going to look at this equation. False is the same as false, so this if statement is true. Because it is true, it will now execute the lines that are in the if statement. So before we were only executing one line, but you can have multiple lines in an if statement. So in this case, it's going to turn the LED on. It will turn the LED on. And then the final thing is interesting. Now we need to let the computer know that the LED is now in the on position. So now I'm going to change the value of LED_on to true. After it sets that to true, I get to a new statement called an else. So the way that an else is set up is if the statement above, that if statement, evaluates to true, then we skip else. If the first if statement evaluates to false, then we run the else no matter what. So the else will execute when the first statement is false. All right, so our LED should be on in this instance. Now we're going to press the button again. And something you may notice is that the state didn't really have anything to do with the change of the LED. We're using a global variable to do that. So we press the button, and let's run it this time with a state of 1. So we send that information to the LED function, and we say that the state is equal to 1. Once again, the state in this case doesn't matter as long as we're continuously tracking that global LED variable. The state isn't super critical. So we have a state of 1. Our global LED is evaluated to a true statement. And so this very first evaluation of the if statement would be that if true equals false. So is true the same as false? And in this case, it is not. So this if statement is false. Because this if statement is false, we are going to skip the lines of code found below in the if statement. Because the first if statement evaluated to false, that means that we execute the else no matter what. So it doesn't matter what the state, we're not even looking at the LED on variable. All we're saying is execute this statement, and in turn it's going to execute it if the LED is in a true condition or an on condition. So we'll execute these 3 lines of code. The first, we're just printing that we've turned the LED off. Then we change the output pin R to a low state. And then we need to reset the condition of the variable LED on. So now we want the global variable to indicate that the light is now in the off position. All right, go to the terminal, and we're going to be executing this lab at 6.2.2. I've also modified in the code, I didn't point it out, but I modified the bounce time, which is the amount of time that it takes between pressing the button. So now, no matter how fast we press the button, we should get a consistent LED on and then an LED off. So if you press it rapidly, you shouldn't see any real change to the way that it works.